All right, it is 2:02. It looks like somebody else is still jumping in, but we'll go ahead and kick it off today. Again, we'll keep it fairly short. We have a little bit of a change of schedule. I think we had advertised we're going to show the some live scanning with the Creaform HandySCAN to go along with the inspection. Currently, I'm right now quarantined with COVID, so so I don't have access to all my normal equipment or scanners or anything that we did or that I normally do. So hope everybody else is staying safe out there. But I've got this basically. I'm going to show a video of our last webinar with the GoSCAN, but it'll fill in just fine with that model that we generated there. It'll fill in just fine for what we need. So again, we'll keep this one rather short, and we'll kick it off here. So let's see. I think we've got everybody in. Again, thank you everybody for jumping in. It's good to see the familiar people that worked with in the past, and to see some new people here. So we'll get started. Let me switch to my slides. So today, as promised, we're doing dimensional inspection for SOLIDWORks. So what does that mean? We're basically taking a SOLIDWORks file and we're going to import it and show some different SOLIDWORks or some inspection techniques. So, and how to go about analyzing those CAD files. All right. So a real quick background. I like to start off, kick off every one of these just in case we have anybody new. Our company, Geomagic Technologies, we were founded in 2003 by our president and CEO, Dan Perot, who has a background in aerospace, by education, an aerospace engineer. Myself, as well as a lot of our other team members, are also have backgrounds in engineering or these types of fields. So we offer products, we sell products, and we sell services that have to do with 3D scanning, 3D printing, reverse engineering, inspection. We also do professional software and equipment training on everything we use. All right, and just give you guys a real quick look at some of our partners we've worked with over the years. So you may see your company on there. To jump right into it though, with 3D scanners, again, we've got our handheld scanners, the ones that we're most, make the bulk of our use. The one we're going to actually show today is the GoSCAN 3D. We'll go over this and the HandySCAN here in just a moment. But the GoSCAN is a totally handheld scanner, accuracy of 0.002 of an inch or 50 microns. We do take 1.5 million measurements per second, so extremely fast. And this is a white light scanner that does scan in color, or we call it texture. So we can actually export a textured mesh or a textured OBJ, which is pretty cool. Again, and for the type of scanner, it is very, very accurate. Just a few snapshots of it in use. So the top left, we do small parts, no problem, because we can do a resolution down to 8 thousandths or about 0.2 millimeters. So super sharp resolution, very pretty much on par with the previous generation HandySCAN. And then you can see it excels in the larger areas because it tracks geometry, so it doesn't necessarily need targets on your part. It'll actually keep a hold of that geometry as you move the scanner field of view across the part. So very cool option, and that's the one I'm going to show in the video. Likewise, the big brother, the HandySCAN Black Elite. This is our premier scanner, so accuracy is actually half of the other one, or should say double. So under 1,000th of an inch. Measurement rate 1.3 million measurements per second, so pretty much on par. This is a blue laser scanner, so we aren't using white light. The blue lasers do give it for a handheld scanner, especially unparalleled ability to scan chrome and shiny and black parts, so no dust, as well as unparalleled resolution, which you'll see in the next slide here. You see down here scanning this chrome wheel. It literally will scan that. It's pretty neat. Something that hasn't really been possible in the 3D scanning world. You got small parts. No longer do you need a tripod white light system to do this sort of thing. We can do it with the HandySCAN. This pretty much covers almost all of our bases, especially for individual component parts. All right, HandySCAN black delete features. These pretty much you can apply to both the HandySCAN and the GoSCAN. So accuracy in real life conditions. So we're not just certifying this in a CMM or metrology environment. We can take this out onto the shop floor and get repeatable dimensions. No rigid setup required because we're either tracking targets on the part or the part geometry. We can negate the impact or severely minimize the impact of vibration and movement of the part. Self-positioning, so no arm or tracker or anything watching these scanners move around. They're completely self-contained. The only thing they're connected to is a cable that's transferring those 1.5 million measurements per second to the computer. On-demand user calibration, so we're going to do a field calibration, a very quick one. It's all of about 30 seconds, and it ensures that your calibration room accuracy is held over into any scanning environment. All right, quick comparison chart. I won't go through too much of this. I'll let you screenshot it here afterwards if need be, but GoSCAN on the left, HandySCAN on the right. HandySCAN, more accurate, can scan any surface without dusting, whereas the GoSCAN does color a little bit faster, but and you know, a little more budget friendly. So those are our two main models. And just for scanning speed, you look at this guy here. This picture always kind of amazes me because resolution of 0.008 of an inch. So there's a point every 0.008 in that mesh on the right side, which is the scan data of the part, the actual part on the left. And you see there for 13 million triangle mesh, it completely scanned and processed that mesh in 5 minutes. When I first started doing this stuff, I couldn't even open a 13 million triangle mesh on my computer. So it is pretty amazing how far we've come. All right, 3D software. So obviously you've got your SolidWorks software. So if you're modeling in that, then you'll generate your CAD file in there generally. Okay. But we also have our reverse engineering and inspection, which inspection we're focusing on today. All right, in 3D scanning workflow, you can see that we've got an object. We have the scanners, you know, as the next step, which capture the scan data. And then that branches in either to generating a model or generating an inspection program of that model. All right, to cap on what the reverse engineering software is, this is our premier reverse engineering software. If you're familiar with reverse engineering, you're likely familiar with Design X. So fastest path from scan to CAD, the most comprehensive reverse engineering software combined history-based CAD with 3D scan data processing. So not only can you edit scan data, you can generate a parametric CAD file from that scan data and get that parametric file in your native CAD program, such as SolidWorks. That's not the one we're looking at today. We're going to look at its sister product, Geomagic Control X, which is our premier inspection program. All right, so what is Control X? A professional metrology software that lets you capture and process the data from 3D scanners to measure, understand, and communicate inspection results to ensure quality everywhere. Why use Control X? It's easy to learn and it's fast and easy to use. As a trainer of this software, I can attest to both of those. It's very CAD-like in its experience, especially mimicking something like SolidWorks. So somebody coming from that user interface is not intimidated by this, like they would be in a lot of others. All right, complete metrology solution. So it's got all the updated tools, all the updated GD&T, everything you could need. Compatible with all 3D scanners. So if you don't have a Creaform scanner and you're saving up for one, you can use this with your current technology. So and then carry it right over to the new scanner, same exact workflow. Okay. What can you do with Geomagic Control X? So you can use it for design, design for manufacturability, find and fix problems, and then for manufacture, identify and resolve manufacturing and assembly issues, eliminate costly scrap and rework. So that's a very large part of our end users' needs. Is a lot of times you find out that you have these fitment problems or issues during the assembly process, and you have to backtrack from there. Control X lets you find those, identify those areas. All right, inspect, solve your toughest measurement problems, improve quality documentation, reduce quality control bottlenecks. That's what we're all about, is speeding things up, reducing bottlenecks. The quicker you can get your parts inspected and have a reliable inspection workflow, the quicker you can identify problems, and therefore the faster you can bring your product to market. Maintain, assess damage, deformation, or wear accurately and consistently, predict part failure before it happens. So kind of going back to the previous point, we can analyze trends in wear or deformation, just like it says. We can see where those how long that process takes before the part becomes unusable, and then we can translate that to future knowledge, to where we know when we need to replace parts that may be wearing out prematurely, or just map their wear lifespan overall, so we don't have to wait for a part to fail and have to manufacture a new one. We can stop it on our time, replace the part, and then pick back up where we left off. So very important tool there. You can see their CAD import, so we can import natively from all these different programs. Today we're going to look at, obviously we're talking about SolidWorks, the biggest user market, and then Polygon import. We can import those different scan data types from, like I said, any number of scanners. All right, so as I'm talking, I'm going to stop the presentation here and start up my video. But as we're doing this, feel free to type in questions in the chat if you have any. All right, and what I'm going to do is start up the scanner video. So those of you not familiar with the Creaform 3D scanners, here we go. Play video.
Let's turn on.
All right, so this is from our last.
So you should be able to see me here in just a moment.
I'm going to go ahead and stop talking and let the video go.
How's it going, everyone? So we're just going to scan this little demo part. It's a gray plastic injection molded piece. I'm going to put that right on my table here. And the scanner we're going to use today is the new GoSCAN Spark from last year. It was one of the 2 handheld scanners that Creaform updated for 2019. It's an awesome scanner. And we'll go ahead and start shooting this part. So I've got the part right there on the table. This is handheld, not connected to anything except for the data cable. And we'll start shooting. So as you can see, this is actually a white light scanner as opposed to Creaform's other laser scanners. And this scanner will capture geometry as well as color. So if you do have artwork and things like that you'd like to recreate in 3-dimensional space with color, this is a great option. And what's really nice with the GoSCAN is it uses geometry to align itself. So, it's big brother, the HandySCAN. You need the targets. I've got targets on the table, but this will align itself based off of the geometry shot to shot. So I'm just going to grab as much data as I need here. I think that should be everything. All right, you can see we've got our parts set in the middle of our table. And set the scanner down. But again, this guy, GoSCAN Spark, accurate to 50 microns, or about 2007 inch. One of the fastest 3D scanners on the market. And we love
it. Okay, so yeah, that's a quick video. Let me go ahead and switch to my screen share here. And we'll start it on my SolidWorks file here. But just as the video explained, so I wanted to show the video that's from our previous webinar where we actually went through the GoSCAN quite a bit. So, but we're going to use that scan data set we took from that session to analyze this part. Now the part, here we go. It is in SolidWorks, so it's a parametric part model. You see Geomagic sample file.sdl or SLD PRT. Okay, we got all of our CAD building features. Now I can take this. What's great is I don't have to export this as an IGES or a step. I can jump over to my Geomagic Control X software. All right, that looks very similar. As we talked about, it looks very similar to SolidWorks. Same basic CAD layout, so it's very comfortable to transition people over to it, even those aren't familiar with the inspection workflow. But we can click right on import, and we can navigate to that SolidWorks part. Click on it, and just import, and it'll pull that file right in. So super easy. All right, there we go. Now, one thing that you do have access to, if you have a license for a what SOLIDWORKS called MDB, or model-based design, which is basically what allows you to do if you have that license in SOLIDWORKS, is to apply MDB dimensions directly to your CAD model that translate to downstream software. So in our case, an inspection software. What's nice with that is I'm going to go through the inspection setup workflow, but it'll obviously decrease quite a bit of that because your dimensions will come in already there, and then you can tweak them as needed. So that's a cool function, and that is right under Menu, File, Import PMI. So PMI being Product Manufacturing Info, which is exactly what that SOLIDWORKS MBD is. Okay, so I don't have that license for SOLIDWORKS, but that's something you can do, and it even helps you further streamline this process. Okay. What I'm going to do is just import the scan directly. So here's a scan from the last month. I'm just going to make sure nobody's saying that they can't see anything. Okay. All right, there we go. So there's my scan, pretty typical. It's just kind of floating out in space where the scanner placed it. This is my sample part. So it's got some pretty cool basic features that we can use. So when I want to get my scan to my CAD file, first thing I need to do is the initial alignment. All right, and that just snaps the scan in a quick best fit on top of the CAD file. All right, now I usually want to take that a step further. With the scans, I always want to do that initial alignment, but now I want to take it a step further. You can do a best fit, or in our case, I can run a datum alignment. I don't have to define the datums right away, which is really nice with this. I can just go ahead and do the alignment and then apply all that stuff later when I'm doing my dimensioning. That way, it kind of lets you be a little more fluid with your workflow. But I'm going to choose maybe this top plane here is a mating face, and that's datum A. And then this face here, you can see the scan update to the CAD file, datum B. And then this circle here is going to be my datum C, okay, or my third datum. All right, so now I've got my datum alignment selected. Okay. And that will finalize that alignment. All right. If I want to see what that surface profile looks like in the datum alignment condition, we can go to the Compare tab, and probably the most common thing everybody's seen with inspection with scan data is the 3D Compare type of tool. So this one's very, very simple to use. Choose our profile tolerance, or overall surface tolerance, and this may be defined in your SOLIDWORKS drawing. It may have an overall surface profile tolerance. And what this will do, I'll make it plus or minus 5, make it fairly tight. And this will tell you in your report how much of your surface is in or out of tolerance. All right, so I can click on a few flagged areas, some places that maybe are a little bit concerning. Okay, and click my checkbox. And now I very quickly can portray this to somebody, let them see it and be like, okay, I can clearly see the areas that at least the geometry is falling outside of where it should, and we can analyze it further dimensionally. So again, if you got any questions as this goes along, I'll kind of try and bounce back and forth. I'll get the questions answered at the once I get finished up here, but feel free to punch them into the chat there, and I will revisit anything that may confuse anybody. I'd be happy to do so. All right, so for the moment though, I've got my 3D Compare in there, so I don't need to see it anymore. I'm going to hide it. And I'm also going to hide my datum alignment because I don't need to really know where those flags are. All right, so now I want to do an actual dimension, or take some dimensions. So we're going to grab those dimensions. Again, if we use that MDB dimensions, if you have that access in SOLIDWORKS, here's where you can maybe just tweak them if you need to. If something didn't translate right, it should. But for us, because we don't have those, maybe we're looking at a referenced 2D drawing from SolidWorks, we can then start to copy those into this software. So I'm going to start with a smart dimension. There's two halves to this. There's the actual dimensions, which we'll get to in this group, and then I'll do another group that has to do with the GD&T functions. So we got linear, angular, radial, and elliptical dimensions, and then a smart dimension. I'm typically in the smart dimension unless for whatever reason I have to specify which dimension I'm going to use. All right, the smart dimension, if you're coming from SolidWorks, again, translates right over. You've got a smart dimension in SolidWorks as well, where you can just click on the feature. In my case, I'll click on this sphere, and you can see it's trying to create a radial dimension. Okay, I can change my tolerance value here. All right, so if I tighten that up, you can see it's going to fail it. And if I have the scan data, it automatically analyzes the scan to the CAD. So it gives you an immediate dimension. Okay, so likewise, with that radial dimension, I can click right on the cylinder, and it does the same thing. It'll pull a radial dimension from that cylinder. I can change my tolerance to whatever I want it to be, and I'm good to go. So that's my second. So just single clicks on certain features will extract the dimension that's required to define that feature. Now, if I go to, let's say maybe my datum C circle down here, and I click on it, obviously it's going to try and create a radius initially. All right, but if I don't click the flag and place it, and I click the sphere up here, all right, now it knows that I'm trying to make a dimension between the two features. So it will give me at that point, a linear dimension. If I want to constrain that alignment, there we go. I can choose the y-axis and then click it out here and apply it. So after that, I can also change my tolerance. Again, I can make that as tight or as loose I want to do. Okay, and the last thing I want to show, smart dimension, just like clicking two features and putting a linear dimension between them. If I click two features that are not parallel to one another, like two planes, it will automatically change that into an angular dimension. So smart dimension is very flexible in what it allows you to grab, and it's very good at predicting what it is you're trying to measure. All right, maybe I make that tolerance plus or minus 1 degree. Now, if I decide if the model is kind of funky and the dimension is kind of, isn't really correct, or, it doesn't round up to something, you can adjust your reference as well. So you can decide to make that an even 35 degrees, and it will take that as the new nominal. So that's a pretty cool, functional option there. Somebody might quite make the model right, or it hasn't been updated, but you know what that updated dimension needs to be. You can override it. All right. Now, I like to have my views of all my dimensions. I don't like to get things too cluttered, and I like to replicate the drawing views. So if you think of a 2D drawing, you're typically going to have a front, a top, and a right view, something like that. So usually you'll have a view with this part that would look kind of like this. Okay, so what I want to do is I want to get normal to that view, and I want to project this view to my report. Okay, so maybe I like this the way this is laid out. I can find, I can go over here in my model tree. All right, and it's laid out very similar to what you'd see in a modeling software, in the tree that groups all of your like tools. So we can see this. We can go down to our analysis tab, 3D GD&T, okay, and group 1. That's the group we're in. I can click on that. There's my default view. I don't like that one. I can reassign the viewpoint. Maybe I need to zoom out just a little bit here. Reassign that viewpoint, and there we go. All right, so now it's all centered out. So that'll be projected in my report with this view. So if you have 20 different dimensions in there that are all pulled very nicely looking from this view, you can do that. All right. For GD&T, I'm gonna hide this view just because I don't want to confuse everything. And I'll click Add New Group just so we're working in a new group. And here's where maybe I'll click my datum. So how do you assign datums? Very easy. Click on datum. It's going to go in order. So datum A, that was our plane. Datum B is this plane over here. And datum C is our circle. There we go. And now I don't have a datum D, but you can see there it's trying to create one. Okay, so I'm going to go ahead and check on out of there and get those oriented correctly. All right, so I've defined datums A, B, and C. And now maybe I want to stick a, now I want to do some GD and T functions, right? So you got these callouts on your drawing, even if you don't know what they are, they're very simple to figure out, okay? The common ones are, especially if you got a flatness symbol on your datum A in your drawing, you can click flatness. You click right on your datum A plane. All right, and let's make that tolerance 10 thousandths. Click it out in space, and you see it'll automatically combine the plane with your datum flag. All right, there we go. Let's move that around. Okay, so we've applied a flatness to that. Likewise, very similar tool, surface profile. If I want to put a profile on this surface, I can click that out in space. Right now it's passing, but you can assign it. You can assign that surface profile to the datum condition, which I think it's going to fail. Yep. All right, and what is really nice with this software is not only does it fail, and you're like, oh, I don't know where it failed. It's failing somewhere. I can go back and I can look at the points and that it took and analyze, what the deviation is. It's kind of the old way of doing it. I can just click on show fitting deviation, and it's giving me a color map of that, of that contour, so I can see exactly where it's falling, in and out of that tolerance band, that surface profile band. So, and that, with points that are paired up with this color bar right here, so I can quickly see what's going on. So it makes a really useful tool. It's very interactive, very visual. So again, somebody who may not really even understand a lot of these can look at it, surface profile, and get the heat map on it and be like, okay, it's somewhat it's fairly self-explanatory there, which is a cool function. All right. Last thing, we've got all kind of stuff. Everything is updated GD and T. So any of these symbols you're going to find in your drawings or find in some sort of stated tolerance you're going to find here. I can do a straightness on maybe this face over here. All right, so again, very easy. I love how I can do show fitting deviation, so you can see the the points, how far out they are from zero. It just makes it very nice. So and very unintimidating to teach people. Going back to easy to learn. All right, so that's a quick overview on the 3D, GD, and T. If you do have some dimensions, now we've just basically used some of the onboard dimensions. I do want to show you that you can do some very odd to take dimensions as well. So, and I'll do it in a 2D cross section just to do something different. Let's say you got a 2D, and I've seen this quite a bit. If you need a dimension of a maximum height between this top surface here and this datum plane here at like exactly at a 2.5 inch offset cross section from our coordinate system. All right, there's not I would say a direct tool that you can just click on that's maybe for that in this circumstance. So I'm in a 2D cross section here. I can click Smart Dimension, and I can just click directly on those two, angles. Just like in 3D, it's going to give me a 2D angle in that cross section. Works just like we've been doing. Now, if I want to do kind of I would say an oddball dimension or something that's not readily evident on how to do, I want that maximum height. What I can do is I can make a point. I can apply a point to this top curve here at its extreme position. And how I do that is first I need a direction to know which way to project it. So I'm going to throw a vector and I need it to go up. It looks like it's already pointing up, so that's great. And all this vector is doing is giving me a direction at which to project a point. So I can click on point. I've got all these different methods for any actual of our built geometry features. We got a bunch of different methods on how to actually extract or build those features, construct them. So I can say extreme position and then click on direction, click that vector, and you see I got an arrow pointing down. I'll flip that up, and for entities, which entity I need to put a point on, I'm going to click that curve. All right, because it's not really an arc, it's like a free-form curve, so I can't just put a circle on it. And you can see there, it puts a point there. And if I hover over the point, it shows me the nominal point as well as the projected point. You can see it's up there, it's just to the right. That's the highest point on the real part in that section. So what's very cool now is just with a little bit of a little bit of creativity here, I found a way to take that point very quickly and accurately. So now this will be an extremely accurate measurement to that point. And that's repeatable as it goes, part to part to part. It's going to pull those same exact, it's going to pull that same exact point from wherever that high point happens to be. All right. Maybe we'll tighten up that tolerance. Yeah, let's give it a little bit of room there. All right, still a little high. You can see there the dotted line is the scan data, and the solid line is the CAD file. So it is a little bit out there. All right, but once we're done with that cross section, we can go ahead and exit that. And you notice the cross section is very similar to sketches. So as you create a new cross section, it asks you where you want that plane, and then it gives you a cross section that looks like a sketch, and then you can dimension it. So again, very transferable in that knowledge and that experience. Once I'm done, that's the workflow. Okay, so again, you got any questions, type them in the chat. I'll get to them here in just a minute. What I'm going to do at the end of the day is I'm now going to go to my Tools tab, click Generate Report. All right, I'm going to choose what I want to keep in my report. This is my report table. Initial alignment doesn't really matter because it just was used to, get the scan close to my CAD file so I could do my follow-up alignment. So I'm going to take that out. And I can even realign what I want to show first. So maybe my 3D dimensions, my group 1 and 2, I want to come first. All right, so I'm going to move them up in front of cross-section because that was like one last dimension. All right, I can pre-populate my report fields. I'm not going to worry about doing that right now. We're going to click Generate, and what that's going to do is bring up our report layout from which you can see up at the top left, export our PDF inspection report. So that'll generate here in just a moment and give us a very easy to read report. You can fully customize these too, which is really neat. You don't have to take the standard layout. You can make your own, and with all your own headers and what you want included. You don't have to have pictures in there if you don't need to. But you can see if I scroll down, I got my nominal, my scan file, the datum alignment. Okay, so with the datum faces called out, 3D compare. You got our group 1, so it looks like a really nice representation of a 2D drawing with dimensions on it. This one I didn't change. I could certainly update it. I'm not all that happy with that automatically generated one, but all I got to do is go back over my report, reassign that viewpoint, click rebuild, and it'll update all my pictures. So it's a pretty nice feature there. All right. And of course, got my cross section. So where it took the cross section in the CAD file and the dimensions there, along with the dimension tables after every feature. So that's the workflow. That's how we take our SolidWorks, directly take our SolidWorks CAD files. If you don't have the ability to transfer your dimensions directly with the model, which is a great feature, we can quickly replicate those dimensions in the actual workflow itself. All right, so what I'm going to do is turn my screen share off. Back to slides. Here we go. All right. So thank you for your time. Here's the Q&A. I'm going to check back through my chat here. Okay. And again, if you got any questions about any of that stuff you just saw, or if you've got any questions in general about the software, let me know. All right, I already got a question in. How do you confirm STL deviation from raw point cloud? So the Tom, I don't know if you're talking about the raw point cloud generated by the scanner. So it depends on the scanner that you're using, whether or not you get a point cloud or an STL. Now with Creaform, we don't access the point cloud. We get the STL from their software, from VX Elements. So I can't see the point cloud there. I can import the STL as points, but I typically am not going to do that. If you have a scanner that does export points that relies on other software to generate an STL, you can just import the point cloud just like you would a scan or like an STL, and it'll work exactly the same. So the actual inspection workflow, all this here works equally as well with scan data that is a point cloud versus scan data that is an STL. There are definitely some advantages with the STL, especially when we get into like reverse engineering. It can pull regions a lot more reliably, I found, with STLs and things like that. But the actual process itself is identical. You get a point cloud from something, it's gonna work exactly the same way. I hope I answered that question correctly. Let me know if I need to clarify that. All right, will the inspection parameters that you're defining be retained when inspecting a batch of parts? Good question. So yes, there's two ways to do that. If I open up my, so let me go back to screen share on. It's going to go kind of funky for a second. Actually, I'm going to go ahead and just share my application window here. Okay, that'll work a little better. So there's two ways to do that. One is if you have a handful of parts that you're doing day after day, and you just want to run it in your model manager tree over here and kind of have a little more control over the process. Once I'm done with my first part, I can right click on it and say add or duplicate result. Honestly, either one works. And duplicate the result from your result data one. So you'll have, so I would say, let's go ahead and do it. Duplicate result. Okay. So now I'm working with result data two. Now it's the same, it duplicated it. So everything is there. But what I can do is go to replace scan data. And if I have a second scan, I'll click on that, I'll go search for that second scan, that second part. And when I import, it's going to rerun the inspection process in result data 2 for that new part. Everything else is going to stay the same. All the tolerancing is going to stay the same. The reporting is going to stay the same. Snapshots, everything. So it'll literally just be a mirrored report updated for the new numbers of the new part. So that's one way you can do it, and that's the most common way, at least for me, because usually if I'm doing a benchmark project or a service project, we kind of have a finite number of parts. We have done it in the past where we've got 100 parts to do. Well, as quick as this is to, duplicate one and replace that scan data and rerun the inspection report, you still got a couple minutes between each one, and that time can stack up. So what's great with Geomagic Control X, out of the box, they give you a tool for that. So no macros you have to write or anything like that. It's under menu, tools, batch process. How this works is you spend all your time scanning, let's say 100 parts over the course of a day. All right, you dump all those scans into a folder on your computer. You get your first part working correctly. So we've got this part done. And now when we go to batch process, we'll point the process to that folder containing all those scans, and we'll give it an export folder to dump all the PDF files from our inspection processes into that folder. So you'll get a hands-off back-to-back batch process inspection running of all of your scans where you don't touch anything. You're just letting the computer run in the background, and spit those reports out one after another A very cool feature that they put in there. You know, just like you said, stock as you get the software. All right. Another great question there. So, all right. I hope that answered both of those for you. You know, both of those questions have been asked so far. Again, anybody else have anything they're curious about? I'll give everybody a few seconds here. And I'll tell you what, while I'm waiting for those to come through, we are actually, I think we have it running currently just a 3D print survey. So just a quick survey to of our attendees and people on our email list. Just a questions asking, you know, how and how long, you know, how have you been using 3D scanning, or what you may look at for, or not 3D scanning, I'm sorry, 3D printing. I'm actually going to put that in. I'm going to copy and paste that link here at the top of the chat. Okay, and we're just asking if you guys have a few minutes to please take that survey. Let us know what you're thinking. What you have, you know, a few different pointers on 3D printing that we're curious about. So again, just posted that in the chat section for you guys to click on and take a look at. It's a real quick survey. It's like a couple of questions. So, all right, great. All right, I haven't seen any questions yet. I'm going to swap over to back to my last slide here. Okay. Okay, there we go. Now we're kind of on the concluding side while we're waiting. I'll give everybody just a couple more minutes on the chat. But just I want to end with our mission statement. So to partner with our clients by understanding their unique requirements and aid in developing, deploying, and supporting effective solutions. So we definitely love to, you know, like I said, partner with our end users and make sure they're all good to go. Actually, I worked with a team of young men today, getting a big scan done for a high-profile project. Had some questions where they had a hang up in the middle of it, and got them going, and they're very, very happy. So when you call to ask questions, you talk to an engineer, you talk to somebody who uses this equipment. All right. Again, thank you everyone for your time. I've got I went ahead and threw my contact info back up there. You can contact me directly, any questions, or if you got any questions regarding sales services or just general info, you can reach out to our main Neometrics contact info@neometricstech.com or call on the main line 888-696-7226. All right, I think with that, let me make sure we got more chat. All right, thank you, Greg, for attending. Thanks for the praise. Yeah, I'll definitely let you guys. Oh, I'm sorry, I just got a notice. So the link that I posted isn't the one that's working. So I'm going to do that now. So the brand new link I just posted is the one for the survey. So I'll give everybody just a second to click on that. And while they're doing that, I will, you know, go ahead and close it out. Ignacio, thank you for joining in. I'm glad to hear you got a lot of information out of this. So, all right. Thank you, everybody, for attending, and have a good rest of your day. And we'll look forward to seeing everybody and talking with you next month at our next webinar.